What type of project have you worked with in terms of carbon innovations and automotive?
I think the most interesting project that we did was a chassis that we built for the V8 supercar organisation in Australia, where they were looking at what were they going to do post Ford Falcon and GM Holden Commodore, and they were looking at what other platform they could use the V8 that they'd developed for those series and the gearbox that they'd developed for those series. So there's a company in Australia that actually put the two together, put the V8 and the gearbox together to make like a transaxle. And they said, can you build a carbon chassis to the current Formula One rule and autoclave cure, all of the safety requirements, and can we have that in sort of about 3 months? And we actually managed to do it. So we cut a plug, made some moulds off it, made a chassis, sent it to them. They had body panels made, and it was a retro-looking 1970s Formula 5000 looking car. The guys from the V8 supercars, a lot of the lead drivers actually drove the car and were really impressed with it, and for a while it looked like it was going to be included in the V8 supercar circus, and then over time I think the Ford got the Mustang so that they weren't worried so much about the loss of the Falcon, and I imagine GM is going to do the same thing. They'll come up with the replacement for the Commodore, and so they've managed to bypass that little episode. But for me, making a chassis to the Formula One rule in sort of 3 months, and then watching it drive around a track was pretty satisfying.
What were some of the challenges you faced with innovation in the automotive sector?
I think it's probably with carbon composites especially, it comes down to cost. There was a Korean car company that flew me up to see them and talk to them about chassis a few years ago, and most of the issues with carbon in automotive come down to cost. So you can imagine a piece of steel that costs a steel panel that costs maybe 20 cents or something for the steel, or maybe say even $2, and it goes through a die and it's made up into a part, and 15 seconds later you've got a panel. And you compare that with carbon at $20 USD per kilo for raw fibre that's not woven. Then you've got to pre-preg it, then you've got to have some sort of core, then you've got to cure it, and it could take even with really, really high speed pre-preg curing systems, it might still be 15 minutes. So the difference in cost there's magnitudes of difference between the two costs, and that's the biggest trouble with composites in automotive applications, and that's why it's really just in that top end. So there's motorsport guys that are prepared to spend money on it, and of course there's the glamour brands of car manufacturers that are prepared to spend money on it, but it's not going to be seen at the lower end. It's not going to be, and the everyday drivers are not going to be made from carbon.